A proportional relationship can be represented by a set of equivalent ratios. In this first example, a proportional relationship is defined by a ratio of 2 cups of oats for every 5 cups of flour. Notice that ratio table strategies generate equivalent ratios of oats to flour by multiplying both quantities in a ratio by a multiplier and by combining like values in 2 different equivalent ratios. These equivalent ratios of cups of oats to cups of flour establish a proportional relationship. In the second example, a proportional relationship is defined by a remote-controlled car traveling at a constant speed of 4 feet in 1 second. Notice that different distances and times on the double number line and in the ratio table are equivalent rates and satisfy this proportional relationship. In this third example, a proportional relationship is defined by 2 equivalent measurements, 100 centimeters in 1 meter. Notice that each set of equivalent measurements in meters and centimeters form an equivalent ratio and satisfy this proportional relationship. A constant of proportionality and its reciprocal relate the quantities in a proportional relationship. For the ratio of 2 cups of oats for every 5 cups of flour, the constant of proportionality is found by dividing 2 by 5 to get 2/5 or 0.4 cups of oats per cup of flour. The reciprocal constant of proportionality is found by reversing the order of division to get 5/2 or 2.5 cups of flour per cup of oats. Notice that a constant of proportionality can be used to generate other equivalent ratios that satisfy this proportional relationship. A table does not represent a proportional relationship if the quantities in the table do not form equivalent ratios. For example, the number of chips in this pattern can be represented in a table, where 3 additional chips are added when the figure number increases by 1. Notice that dividing each figure number by the corresponding number of chips generates a different value for each figure in the pattern. This means that pairs of quantities in this table do not form equivalent ratios and do not form a proportional relationship. Note, because the quantities in this table are not proportional, ratio table and multiplier strategies cannot be applied to find the number of chips in a given figure.